Hey everyone, we're going to get through this front page of notes before we get to the examples. So step one is to write this down. What is an identity? Trigonomic identities are a fun piece of trig pre-calculus unit that a lot of kids are scared of, but I think it's fun. Some algebra review with trig functions. So what is an identity? You're writing this down? An equality, so something that's equal, that is true for every value of the variable. Where both sides are defined. So if you have this equals this, then it's a true statement. That's what an identity, think of your identity as you're true to yourself. So an identity in math is a true statement. We're going to use this triangle down here, not for the top here. It's kind of like a typo. We kind of want it down here, but it's a triangle that you know from the test and stuff. Okay, this is going to be new. So these are new memorization. I'm just going to memorize them a different way. So instead of saying sine is y, these are going to be called the reciprocal identities. So sine, we're going to say it's the reciprocal of the cosecant function. Okay, because we know cosecant is 1 over y, and so sine is the reciprocal of cosecant. All right, this just means they're reciprocals of each other. Cosine is the reciprocal of secant, and secant is the reciprocal of cosine, like that. Tangent is the reciprocal of cotangent, and cotangent is the reciprocal of tangent. So these hold true to our prior definitions. We're not making anything up, we're just rewriting them a different way. Okay, you guys know that now I only want the answer here. So I'm going to prove that. Where do I prove it? Maybe right here. What's tangent equal to? Tangent is equal to y over x. But what's y equal to? Y was sine, and what was x? Cosine. So this is called the quotient identity of tangent, is that tangent is equal to sine over cosine, which would mean cotangent is equal to cosine over sine. Do you see how tangent is here and here? So this one over here is called the reciprocal identity because this one says tangent's the reciprocal of cotangent. This is called the quotient identity. Tangent's equal to sine over cosine. These mean the same. They're all equal, they're just written differently. All right, these are a lot of fun, the Pythagorean identities. So on your last test, we wrote the Pythagorean theorem for x, y, and 1. So it starts off like this. X squared on the unit circle, any x squared plus y squared would equal 1 squared, right? Okay, but you ready? What is x equal to? What do we know x to be equal to? X is equal to what function? Cosine, that's right. And what's y equal to? Sine. Look at that substitution. We know 1 squared is 1. So isn't that cool? So cosine squared plus sine squared equals 1. That's a very, very popular, called the Pythagorean identity. Now, we don't want to write these parentheses every time. So there's kind of like a shorthand way to write this, and we're just going to stick that 2 there. Now, you're only allowed to do that if you know what it means. This means all of cosine of theta is being squared. We do not want to mistake that as the cosine of theta squared. Do you get that? The theta is not being squared. That's why we stick the 2 there. Okay, that's the first Pythagorean identity. Cosine squared plus sine squared equals 1. Cosine squared plus sine squared equals 1. Now there's 2 more that are derived from this one. So I'm going to start with cosine squared plus sine squared equals 1, like that. All right, what I'm going to do, because it's fun, this is how these were just discovered, you guys. People were playing with math and someone said, what would happen if I divided this by cosine squared and I divided this? So the whole thing, let's divide the entire equation by cosine squared. I wonder what would happen. Well, let's see. What is cosine divided by cosine? What's anything divided by itself? Bam, 1. Okay, watch this. Sine over cosine. Wait a minute, I've seen that before. Where up here is sine over cosine? Sine over cosine is what? Tangent. So if this says sine squared over cosine squared, we can turn that into, drumroll, tangent squared. Cool? All right. What's this? 1 over cosine squared. Where is 1 over cosine? Up here. Where's 1 over cosine? 1 over cosine's what? Secant. Say secant. Not second, secant. So this is going to be secant squared. Isn't that cool? Now we have a second Pythagorean identity. Cosine squared plus sine squared equals 1. 1 plus tan squared equals secant squared. All right, let's do another one. We're going to continue with our original cosine squared plus sine squared equals 1. And now this one we divided by cosine. So pretend you're a mathematician in the 1600s. What else could you do? We divided by cosine squared. So what's like another option? What's cosine's partner? Let's divide by sine squared. Everything. Divide one thing, you have to divide everything. You know that. All right, what's cosine over sine? Oh, right here. Cosine over sine is equal to cotangent. So this becomes cotangent squared plus sine squared over sine squared. So anything divided by itself is 1. Okay, and then what's 1 over sine? 1 over sine, where is this? Cosecant. This is going to be cosecant squared. All right, these are your formulas. You know, we're going to have these memorized. We're going to have a memorization quiz on these. Reciprocal, quotient, Pythagorean. It's not that hard. Every American teenager memorizes them, so you can do it too. Before we get into identity practice, we need to review some pre-algebra math. Are you ready? Here we go. So, x plus 3 times x minus 3. X times x. X times negative 3. 3 times x. 3 times negative 3. X squared minus 9. You're going to have to write small, but we can do that. Okay, so if that's how we do that, how are we going to do this? Watch, it will be fun. Sine times sine. How did I write that up here? How did we write sine squared? We wrote it like this. Okay, good. So we're going to do that here. Sine times sine is sine squared theta. Sine of theta times negative 1 minus sine theta. Positive 1 times sine will be plus sine theta. Oh yeah, I didn't really say it out loud, but what happens to the 3 x's here? Cancel out. Do you remember what this is called? Difference of 2 squares. Because we have a difference of 2 squares, x squared minus 9. You're right, I didn't finish this. Sine times sine, sine squared. Sine times negative 1, negative sine. 1 times sine, plus sine. Now I have to do positive 1 times negative 1. Positive times a negative is a negative. And this final answer here is sine squared theta minus 1, because what happened to the 2 middle terms? Hiya, they cancel. Okay. So whatever we learned in algebra, we're doing it with trig now. How do we factor this? Oh, it's a difference of 2 squares. So this is going to factor, put your equal sign, x plus 7, x minus 7. Right? That's it. What the heck? How do we factor this? What do you think? Cosine squared minus 1. So here we had x squared, and we wrote it as x times x. And this says cosine squared. So we're going to write that as cosine, and this is a minus 1. Let's see here. I had a plus 1 minus 1 became minus 1. Plus 7 minus 7 became minus 49. Plus 3 minus 3 negative 9. So I have a minus 1. It's going to be plus 1 minus 1. A difference of 2 squares, but with a cosine instead of an x. Sorry about I have ink. How are we doing? Good. Algebra 1, Algebra 2. Algebra 1, Algebra 2. Here we go. Tell me what you need to add fractions. In order to add fractions, we always need a what? We need a common denominator. And you need to make your own common denominator if you don't have one. Do we have a common denominator here? No. So we're going to make our own. We're going to say 1 over sine of theta. How do I turn a 1 into a common denominator? Sine over sine is 1, right? Is our denominator the same? Yep. So now I'm going to add the numerators and leave the denominator the same. Okay, do we have a common denominator here? No, this is over 1, and I need it to be cosine, so watch. I'm going to multiply cosine over cosine. I know you have to write tiny. So we have 1 over cosine plus, ready for this? What is cosine times cosine? Cosine times cosine is going to be cosine squared. All we're doing is making a common denominator. And then adding. That's it for that one. Try and... All right, how am I doing on time? 4 more minutes. Can we do it? Yes, we can. Okay, what's the denominator here? Sine. How do I turn a 1 into a denominator of sine? It's going to be sine. That's a theta. It's an ugly one. Sine over sine, right? Okay, add the numerators. Numerator is going to be cosine plus sine. And the denominator stays the same, sine. Good job. You made it through the adding row. Last two, dividing fractions. Remember how to divide fractions? We take the numerator, and it stays the same. So 1 over sine of theta stays the same, and then we multiply by the reciprocal. So it was cosine over sine. We're going to flip that. We're going to multiply by sine over cosine. Multiply by the reciprocal. Oh, what happens to the signs? They cancel. The signs cancel, and we're left with 1 over cosine. And what's 1 over cosine? Look up here. Secant. All right, 1 over cosine is secant. So we can rewrite, you can leave it 1 over cosine, or you can say, I know what that is. That's secant. Ta-da! All right, look at this fun one. The numerator. Don't be scared. Lots will cancel. Hopefully, maybe, we'll see. I'm going to leave the numerator like this. The first two levels, level 1 and 2, and then level 3 and 4, we're going to do the reciprocal. We're going to flip it. All right, look at that for a second. What do you see? Anything cancel? All right, we know the cosines cancel because they're factors. Now think of this sum and this sum. The sum of sine plus cosine, is that the same as the sum of cosine plus sine? Yes, it is. So these get to cancel also. Okay, what happens when everything cancels off the top? What do we get? 1 over, and what's left on the bottom? Just sine. All right, what is 1 over sine equal to? Let's look up here. 1 over sine is now cosecant, because the reciprocal of sine is cosecant. Oh yeah, I remember that. Cosecant. Okay, guess what? I have a little secret to tell you. We're going to see all of these in our work today and tomorrow. Okay, that's why we did the prep work here. It looks a little messy. Hopefully you followed along. And then the examples on the back, the teacher will do with you. I have a little joke for you. Okay, ready? Have you seen this yet? It's not even summer and I already have a tan. Why? Why is that funny? Why is that a tan? Why is that a tan? Because look right here. Tangent is equal to sine over cosine. That's it. That's my joke of the day.